can see the phi is a plus bi cubed, where a and b are real. Question A, in terms of a and b, find the real part of phi and the imaginary part of phi. To say what is the real part and what is the imaginary part, a given complex number should be represented as something without I plus I multiplied by something also without I, and then it's the real part and it's the imaginary part of a complex number. So definitely here we need expand given expression and just using the binomial formula we can do that. And we need coefficients. Coefficients are 1 to 1 is 4 squared, and then what, 3 3 1 1 4 cubed. So phi becomes 1 a cubed times bi to the power 0, which is 1, plus 3 a squared bi to the power 1 plus 3 a to the power 1 bi squared, and plus 1 a to the power of 0 and bi cubed, and it becomes a cubed plus 3a squared bi. I squared is -1, so it's minus 3ab squared, and I cubed is I squared times I, so it's -I, so it becomes minus b cubed I. And finally it becomes a cubed minus 3ab squared plus I 3a squared b minus b cubed, and hence the real part of phi is a cubed minus 3ab squared, and the imaginary part is 3a squared b minus b cubed. Question B, hence or otherwise, shows that 1 plus root 3i cubed is -8. You can see that it's absolutely the same. For a is 1 and b is root 3, so we can use the obtained expansion to find 1 plus root 3i cubed. So it becomes 1 cubed minus 3 times 1 times root 3 squared plus I 3 times 1 squared root 3 minus root 3 cubed, which is 1 minus 9 plus I, it's 3 root 3 minus root 3 cubed, it's also 3 root 3. So you can see that it's just 1 minus 9, which is -8, plus 0 I, so it's -8 as required. The next, the roots of the equation z cubed is -8 are u, v, and w, where u is 1 plus root 3i and v is real. Question C, write down v and w given your answer in Cartesian form. So what should we know about roots of the equation with complex numbers? So if it's z cubed, there are 3 roots in total, and all 3 roots are equally spaced. What does it mean? It means that 360 divided by 3 is 120, so there are 120 degrees between any consecutive roots. And also we should know, if a complex number is a root, complex conjugate also is a root, and complex roots arise in pairs. And since it's z cubed, there are 2 complex roots, and the third, it will be real. What is complex conjugate? We just replace every I by -I. So the next root, it's w, it's 1 minus root 3i, and since v is real, and it's quite clear that -2 is the root, because -2 cubed is -8, so v is -2. The next, on an organ diagram, u, v, and w are represented by the points u, v, and w respectively. D, find the area of a triangle u, v, and w. So let represent UV and W on the organ diagram. X-axis is the real part, y-axis is the imaginary part, and point U is somewhere here with coordinates 1 and √3, and symmetrically about x-axis it's what, W, which is 1 minus √3i, so it's negative √3, and V is somewhere here, and x coordinate is negative 2. And we need what? The area of UVW. And just applying half times base times height. If we choose UW to be the base, you can see that distance is what? 2 √3. And height is this distance, it's what, 2 units and 1 unit, so it's 3 units in total. So finally it's 3 √3. The next, each of the points UV and W is rotated anticlockwise about origin through an angle of pi over 4 to form 3 new points, U primed, V primed, and W primed. These points represent the complex numbers U primed, V primed, and W primed respectively. Find U primed, V primed, and W primed, giving your answers in the form RE to the power I theta, where theta is greater than negative pi and less or equal than pi. So if we represent UV and W in the form R e to the power I theta, it's the modulus argument form, or the Euler's form. I is the distance from origin, and theta it's the argument, it's the angle. 0 is here. In anti-clockwise there are positive angles, in clockwise there are negative angles. And if we do rotation only, modulus remains the same, so distance from origin remains the same, but this angle what increases by pi over 4. Why increases? Because we rotate in anti-clockwise. It's positive direction for angles, and the corresponding argument just increases by pi over 4. So we need represent UV and W in modulus argument form, or it's actually the Euler's form, and then just increase the argument by pi over 4. So U is 1 plus √3i, and it's what distance from origin or modulus, it's what, just square root of x squared plus y squared is 2, or all 3 roots have the same distance from origin if we consider that cubed is negative 2, and since v is 2 units from origin, so definitely all other also will be 2 units from the origin. So modulus is 2, and argument is it can be found as tangent theta. You can see that it's what, it's √3 over 1, and tangent to be √3, it's what, 16 degrees, or pi over 3 in radians. Or you remember that there are 120 between two consecutive, and so this angle between what U and W is also 120, and definitely due to symmetry this argument is just a half, so 60 degrees. So it becomes I e to the power I and pi over 3, and then U primed becomes 2 e to the power I and pi over 3 plus pi over 4, and common denominator, it's 12, so it's what, 7 pi over 12. It's less than pi, and what, greater than negative pi. The next point is v, which is -2, but notice that it cannot be -2 in modulus argument form. It's 2, because modulus it's positive, it's distance from origin to, and angle it's 180, or pi in radians, so it's 2 multiplied by e to the power I pi. It cannot be -2 e to the power I 0 or something like that, or just -2. And then v primed, it's 2 e to the power I pi plus pi over 4. Definitely we can calculate it, but since theta must be less than pi and greater than -pi, you can then in general you can add or subtract any number of 2 pi, any number of full revolutions, to get an equivalent angle and equivalent argument, but I see that it will be greater than pi, so I subtract 2 pi now, so it becomes pi minus 2 pi, so it's minus pi plus pi over 4, and pi it's what, 4 over 4, so it's 2 times e to the power of negative, oh, let's write just, oh, okay, negative 3 pi over 4, which is greater than -pi and less than pi. And finally w, it's 2 e to the power I, and it's what, it's also 60 degrees, but in clockwise direction, so it can be represented as negative pi over 3, or it can be represented as 300 in degrees as positive, or you may represent as 2 pi minus pi over 3. It doesn't matter. I will write negative pi over 3, and w prime becomes 2 e to the power I negative pi over 3 plus pi over 4, which is 12, so it's negative pi over 12. The next, given that u prime, v prime, and w prime are the solutions of z cubed dc plus di, where c and d are real, find the value of c and the value of d. So since something is a solution, definitely if we substitute it for z, it must be true, and we can choose u primed, v primed, or w prime, it doesn't matter, but since it's cubed, I see that it will be more easier to use w primed, so we can say that w primed cubed is c plus di, and w primed is what, 2 e to the power of negative I pi over 12, and then cubed, it becomes 2 cubed, it's 8, and e to the power of what, we should just what, to multiply exponents, so it's a negative pi over 4. Pi over 4 it's 45 degrees, so it will be easy to calculate, and just applying a formula to get the Cartesian form. Formula is given in a data booklet, and it says that it becomes modulus cosine of negative pi over 4 plus I sine of negative pi over 4. Cosine, it's it's even function. It's cosine of negative pi over 4 is the same as cosine of pi over 4, and it's root 2 over 2. And sine is odd function, so sine of negative angle, it's negative sine. And sine of 45 degrees of pi over 4, it's also root 2 over 2. And expand to get 4 root 2 minus I times 4 root 2. Or 4 root 2 I. Hence, C is 4 root 2 and D is negative 4 root 2. The next, it is given that u, v, w, u primed, v primed, and w primed are the solutions of z to the power of n is alpha for some alpha is complex and is natural. G, find the smallest positive value of n. Notice that these six values are not the all possible roots. It's just a part of roots. And let represent all six values on the organ diagram. Let's do it here. So u, it's I can write in degree, or actually okay, it will be more easy in degrees, and actually it's not necessary to write this, it just to understand how to find. So it's 60, then here it's also 60, and it's v, it was here, I will write small, doesn't matter, it's w, and then primed, u primed is plus 45, it's 105. So it's 90, so it's 50, there are 15 degrees here, and v primed, so it's 45 here, and w 60 minus 45, w is somewhere, primed is somewhere here, so that there are 15 degrees here. And let's find angles between consecutive values. What do I mean? You can see that there are 60 plus 15, 75 degrees between u and w primed. Then you can see that u primed, there are what, it's 30 plus 15, 45. Then between these it's 75, then 45, then it's 45 also 75, and 45 between w and w primed. And again, using the idea that if we consider some equation that to the power of n is equal to something, and there are n roots in total, and part of these roots are represented by these six complex numbers, and the idea is that all n roots must be equally spaced. What does it mean? There must be 316 over n, such angle must be between any consecutive angles. And you can see that all these values are multiples of what? Definitely of 5, but we need the greatest number. Why the greatest? Because n must be the least, or there must be as least as less as possible values of roots, and the greatest common factor is 15 degrees, and all these values are multiple of 15. So what does it mean? It means that if I divide or add complex numbers, possible roots of this z to the power of n, it is possible that all n roots will be spaced by 15 degrees. And then 360 divided by 15 is 24. So the least possible value of n is 24. So z to the power 24 has 24 roots, and angle between consecutive roots is 15 degrees. So 24 roots all around, 4 false revolutions, and 15, and our u primed, v primed, w primed are somewhere here, because they all are multiples of 15. So how to answer? So we can see 3 marks. Find the smallest positive value of n. So we can give the answer as follows. So we can say that arguments between or we can say arguments are differ by and this, and then we can say that the successor is the greatest common factor is 15 degrees, and then n is 360 degrees over 15 is 24, and it will be enough to find the smallest positive value of n. And that's all for this question.